Multiplying matrices. All right, as always, your state standards are listed and your success criteria. Today, to be successful, you need to be able to determine whether a product of matrices is defined, multiply matrices, and use a matrix multiplication to solve real-world problems. All right, key idea. This is a little different than adding and subtracting matrices. Remember, adding and subtracting matrices, you had to have the same size matrix. Multiplying is a little different, so pay attention. The product of two matrices, A and B, is defined provided the number of columns in A is equal to the number of rows in B. Remember, we identify matrix rows by columns. All right, so if A is an n by n matrix and B is an n by p matrix, then a product AB is an m by p matrix. All right, so here's an example. So if you've got an m by n and you got an n by p, if the two numbers here, I say numbers, if the two letters here are the same, then you can multiply the matrix. And the matrix will be m by p. That will be the dimensions of the matrix. All right, multiplying matrices. All right, to find the element in the ith row and the jth column of the product matrix AB, multiply each element in the ith row of A by the corresponding element in the jth column of B, then add the products. All right, so you can see the example here. You've got A, B, C, D, and E, F, G, H. And if we multiply the first row by the first column, that produces AE plus BG. And that gives us our answer that goes in the element for the answer matrix. And you can do this in your calculator as well, but it's important to know if you have a question on the state test that's on the non-calculator portion, you need to be able to do that. So make sure you are aware. We will practice this, and hopefully it's not too bad. All right, describing matrix products. Determine whether the product AB is defined. If so, state the dimensions of AB. Describing matrix products. Example 1 says, determine whether the product AB is defined. If so, state the dimensions of AB. All right, so we can see here that it has 2 rows and 3 columns. So matrix A has 2 rows by 3 columns. All right, matrix B has 1, 2, 3 rows and 1, 2, 3, 4 columns. So it is a 3 by 4. If the columns of the first matrix is the same as the rows of the second matrix, then that means it is defined. So this one is defined, and 2 by 4 is your dimensions. So the dimensions of matrix A times matrix B will be a 2 by 4 matrix. All right, B part has matrix A and B as well. So we have 2 rows by 3 columns. So we've got 2 rows by 3 columns. Matrix B is also 2 rows by 3 columns. Because these do not match, all right, those are not the same, that means the product, the multiplication of AB is not defined. So this one is not defined. So we cannot multiply those because the dimensions do not work. Find the product of 2 matrices. All right, example 2, again, here's our key idea. This is in words and this is algebraically how you multiply 2 matrices. All right, so it says find AB. A is a 2 by 2, B is a 2 by 2. Because the inside dimensions are the same, that means we can multiply these 2 matrices. So we're going to do that by multiplying the row by each column, all right, and then the row by this column goes here, and then the second row by the first column goes here, and then the second row by the second column, the answer goes here. All right, so let's go ahead and try that with this first example. All right, so I have A and B. So I'm going to have 3 times negative 1. So 3 times negative 1 is negative 3 plus 2 times 6, which is 12. And then I'm going to do the first row by the second column. So 3 times 4 is 12. And 2 times 5 is 10. All right, and then I'm going to do the second row by the first column. So negative 7 times negative 1 is plus 7. And then 8 times 6 is 48. And then I'm going to do the second row by the second column. So negative 7 times 4 is negative 28. And then 8 times 5 is 40. All right, so now all you have to do is combine your numbers. So negative 3 and 12 is 9. 12 and 10 makes 22. And 7 plus 48 is 55. Negative 28 plus 40 is positive 12. So that would be the answer to my matrix when I multiply matrix A times matrix B. All right, take just a moment. I want you to use these steps to see if you can multiply these two matrices together. Again, 2 by 2 by 2 by 2, so you can multiply these matrices. Remember, you're going to do the first row by the first column, the first row by the second column, and then the second row by the first column, and the second row by the second column. So you're basically multiplying everything by everything. All right, pause the video, try to do this, and then come back to see how you did. All right, let's look at multiplying these two matrices. All right, so we're going to start out with 3 times 2, which is 6. And then we're going to have negative 1 times negative 1, which is plus 1. And then we're going to have 3 times 3, which is 9. And negative 1 times 4, negative 4. And then on the bottom row, we're going to have 2 times 2, which is 4. And 4 times negative 4, or 1 is negative 4. And then the last row by the second column, so 2 times 6 is, 2 times 3 is 6. And 4 times 4 is 16. All right, sometimes I get a little ahead of myself. All right, 6 plus 1 is 7. 9 minus 4 is 5. 4 minus 4 is 0. 6 plus 16 is 22. So if I multiply these two matrices together, it is defined, and this is the product of those two matrices. Now, common error. Order is very important when you are multiplying matrices. If you reverse the order, then you're going to get a different product matrix. So because it's a 2 by 2, you can multiply, like in this case, matrix A times matrix B. You can multiply B times A, but you're going to get a different product matrix than you will if you do A times B. So the product of A times B does not equal the same thing as B times A. Unless they have the same elements, that would be the only exception to that. Or maybe if you're multiplying by the identity matrix. But in general, switching the order will not produce the same result. So when it says multiply A times B, make sure matrix A is on your left, matrix B is on your right, and then you multiply it using this pattern here. All right, some other key ideas that you need to be aware of. So the M by N identity matrix is a matrix that consists of ones on its main diagonal from top left to bottom right, and zeros for all the other elements. So if you see a matrix that looks like this, this is called the identity matrix. This is the identity matrix for a 2 by 2. This is the identity matrix for a 3 by 3. If you wanted to know about the identity matrix for a 4 by 4, you would add another 1 in the corner and zeros everywhere else. So if A is an N by M matrix and I is an N by N identity matrix, then AI equals A and IA equals A. So if you multiply a matrix by the identity matrix, you're going to get the same matrix back. It's like the multiplicative identity for real numbers, which is the study tip here. The number 1 is the multiplicative identity for real numbers because a times 1 equals a for any real number. All right, so that's the same thing we're looking at here for the identity matrix. If you have the identity matrix and you multiply by matrix A, you're going to get the same matrix A back. All right, so properties of matrix multiplication. Let A, B, and C be matrices. Let I be the identity matrix, and let K be a scalar. Remember in the last lesson we talked about a number multiplied by a matrix. That's a scalar, and that's just called scalar multiplication. All right, so these are properties that you need to be aware of for matrices, very similar to real numbers. Using matrix operations. So example 3 says, use the given matrices to evaluate A times B plus C and AB plus BC. All right, so the first one says A times B plus C. Since B plus C is in parentheses, you can go ahead and add those first. So we're going to have matrix A, 5, 7, 3, 1, negative 4, and 2. So that's matrix A. And we're going to multiply that by B plus C. So B plus C, remember we add corresponding elements. So 0 plus 2 is 2. 1 plus negative 3 is negative 2. 3 plus negative 1 is 2. And negative 6 plus 5 is negative 1. All right, and again, we have a 1, 2, 3 rows by 2 columns. We have a 3 by 2 and a 2 by 2. So those will multiply. And our resulting matrix is going to be a 3 by 2. So when we multiply these, we get a 3 by 2. So review just a second. This is matrix A, just exactly like it is copied down. This matrix here is B plus C. So we took B and added it to C to get this matrix. Now we have to multiply these two matrices together. So we're going to have 5 times 2 and 7 times 2. That's our first element. All right, and then we're going to have the first row by the second column. So 5 times negative 2. And 7 times negative 1. All right, then we're going to do the second row by first column. So 3 times 2 is 6. And 1 times 2 is 2. Then we're going to do the second row by the second column. So 3 times negative 2. And 1 times negative 1. And then we have to do the last row by both columns. So let's do the last row by the first column. Negative 4 times 2, negative 8. And 2 times 2 is 4. And then we're going to do the last row by the second column. Negative 4 times negative 2 is positive 8. And 2 times negative 1 is negative 2. All right, so that's our matrix. Now we just have to simplify. All right, so 10 plus 14. 10 plus 14 is 24. Negative 10 minus 7 is negative 17. 6 plus 2 is 8. Negative 6 and negative 1 is negative 7. Negative 8 plus 4 is negative 4. 8 minus 2 is 6. So that is our matrix. So this matrix represents A times B plus C. All right, take a moment, see if you can do B part, and then come back to see if you get the right answer. All right, because of space, I didn't write everything down. So A times B produces this matrix here. B times C produces this matrix here. And then if I do AB plus BC, I get this matrix, 24, negative 17, 8, negative 7, negative 4, 6. Hopefully you realize that is the same thing here. So in this case, we added BC first and then multiplied by A. This time we multiplied A times matrix B and we multiplied B times matrix C, and that gave us the same answer. All right, so